Wild plum represents one of the earliest wild harvested stone fruits across both continents. Unlike cultivated commercial plums, which are typically large, glossy, juicy, sweet, and uniform, the wild plum is smaller, tart, intensely aromatic and genetically diverse. Wherever ancient civilizations existed in temperate regions, wild plums were part of the prehistoric food landscape. The wild plum predates orchards, agriculture, horticultural domestication, and even early trading systems. The scientific background of wild plum spans several species. In Eurasia, Prunus domestica has deep ancestral ties to primitive plums, sloes, and cherry plum species. In Africa, wild plum relatives thrived in savanna belts, serving as seasonal food for pastoral populations. In North America, wild plum species such as Prunus americana, Prunus angustifolia, and Prunus hortulana shaped indigenous seasonal diets. This multi-origin structure makes wild plum one of the most widely distributed ancestral fruits in human history. The defining characteristic of wild plum is variability. No two wild plum trees produce identical fruit. Flavor intensity ranges from sharp lemon-like acidity to mild sweetness with a resinous note. Coloration ranges from deep violet and dark burgundy to orange, amber gold or dusty rose. Skin thickness is biologically strategic. Thicker cuticles protect pulp from insects, dehydration, and pathogens. For this reason, wild plum has an extended natural shelf life, something modern commercial plums lost through breeding focused on softness and sweetness. The earliest use of wild plums was not fresh consumption. The fruit was often dried, cooked, mashed into pastes or fermented into primitive alcoholic beverages. Archaeological findings report preserved plum seeds in early settlements in Central Asia, Southeast Europe, Anatolia and early agricultural zones near the Tigris-Euphrates basin. The pits of wild plum appear in burial sites and ritual assemblages, indicating symbolic function in funerary rites. In early societies, wild plum served several key roles: food source, seasonal harvest, often essential during winter, preservable nutrient, sun-dried or smoked, maintaining nutritive value, medicinal agent. Dried wild plum flesh was used to regulate digestion, particularly in cultures practicing dried fruit medicinal diets. Pigment source. Certain wild plum skins produce natural anthracene and dyes applied in textile coloring and ceremonial markings. The wild plum also played a large ecological function. Many early fruit-bearing species relied on megafauna for long-distance seed dispersal. Later, birds, foxes, bears, and wild boars consumed plums, carrying pits across forests. Wild plum trees often colonized riverbanks, slopes and rocky hillsides. This explains their widespread presence across regions long before human orchard establishment. Genetically, wild plum is considered a bridge fruit. Modern plums are hybrids of multiple ancestral plum types. The more refined sweetness, thin skin, uniform size and softer mouthfeel of modern plums emerged through repeated grafting, selection and controlled pairing. However, wild varieties carry critical defensive genes, resistance to fungal rot, tolerance to drought, adaptability across soil pH conditions and frost resistance. Many modern rootstocks used in commercial orchards originate from wild plum genetics, not from cultivated plums. The deeper root penetration of wild rootstock prevents water stress, enabling orchard sustainability in drier climates. One of the most niche and lesser-known areas of wild plum research relates to polyphenol density. Wild plums contain significantly higher antioxidant concentrations, particularly neochlorogenic acid, quercetin, cyanidin-3 glucoside, and rutin compounds. These compounds are associated with anti-inflammatory and antioxidative benefits. The bitterness of wild plum, especially its skin, is directly correlated with these compounds. Flavor chemistry in wild plum is stronger than in commercial plums. The fruit contains aldehydes and esters giving characteristic sharpness. Stone fruits often share almond-like aroma compounds because of trace cyanogenic elements near the pit. Wild plum demonstrates this more prominently. Historically, wild plum trees became culturally coded symbols. In early Chinese dynasties, plum blossoms represented endurance and rebirth, surviving frost while flowering. In ancient Mediterranean civilizations, wild plum groves marked settlement stability and resource continuity. In the Slavic cultural zone, fermented wild plum beverages evolved into traditional spirits. In the Caucasus, wild plums were processed into thick fruit leather sheets for winter consumption. These sheets later influenced modern confectionery systems. Wild plum evolution into modern plum agriculture reshaped fruit economics. After orchard stabilization, European plum cultivars spread into North America. Yet indigenous communities already had local plum varieties deeply rooted in their food traditions. These native plums were not replaced. Instead, interbreeding occurred between imported and existing species. Today, some modern plum cultivars trace the genetic identity to Native American wild plum lines. Modern interest in wild plum resurged due to biodiversity decline in orchard systems. Conservation programs now maintain wild seed banks. Wild plums are crucial for future fruit breeding, not for sweetness, but resilience. To summarize, wild plum is not simply a sour primitive fruit. It is the evolutionary foundation that produced hundreds of commercial plum cultivars. When modern plums became fragile through selective breeding, wild plum genetics preserved durability. Its symbolic, nutritional, agricultural and ecological contributions make wild plum one of the most historically influential fruits in the temperate world. Wild plum remains not just a remnant of ancient forests, but an active genetic reservoir shaping tomorrow's orchard systems.